What is going on, guys? Today we're gonna start creating a platformer game in Godot 4. In this first video, we're gonna lay the foundations and start the beginnings of a platformer controller. Create an empty project and let's get started. I'm gonna start by creating a 2D scene, which is going to be the world, and this will be the main scene that we're gonna work with. Let's save this. I'm gonna create a new folder for my scenes. Save the scene here. And let's also make this scene the main scene by running the game and picking select current so that this scene is the main scene. Okay. Now we can start working on the platformer controller, the main player scene. This is going to be a new scene, and this will be a character body 2D. This is going to have a sprite 2D and a collision shape 2D. For the sprite, we're going to use the default Godot icon for now. I don't have any assets yet. In a future video, I'm going to bring in some assets, but for now, we're just going to use this guy. Let's make him a little thinner and move him up just like that so that the center point of the scene is at the bottom of the sprite. Now I'm going to create a collision shape. And for the shape, I'm going to use a rectangle. You can also use a capsule, although the capsule tends to slip from edges. So that is going to be a preference thing. So if you want the player to, slip from edges, use a capsule. But if you want them to stay on an edge, even if the player is right at the end, use a rectangle. Let's make it the correct size. Okay, let's rename the scene to be the player and save it in the scenes folder. Now we can go back into the world and instance a player here. Put him in the center, run the game. There he is, looking good. Now we can go back into the player script. Not the player script, to the player scene and create a player script. For the script, we're going to click on the new script icon. And I'm going to create a new folder. Let's go back into the root directory and create a folder here called scripts. We can save our script here and create it. I'm going to bring in the physics process function, because whenever we want to make a physics body, like the character body move, we need to do it inside the physics process. And to make it move, we're going to have to call the move and slide function. But move and slide by itself isn't going to have any effect because we need to set a velocity. Velocity is a vector too, so it has an x and a y property. To make the player move left to right, we're going to set the x property. So for example, we can say velocity.x equals 300, and this will make the player move to the right. Let's see this in action. You can see that the player is going to the right. We can set this to be a negative number, like negative 300, and this will make the player go left. The same is true for the y, but we're not going to make the player move on the y because we are going to make him move, but we're going to have a gravity that pushes the player down if the player isn't on the floor, and we're going to have the ability to make the player jump. So let's take care of left to right movement first. We don't want to set a value like 300 here. We want to take input from the player and then set the value based on the input. So let's go into the project settings. Oops, what did I do there? No, don't check that. Let's go into the project settings, input map. And as you can see, I have some input actions that I prepared beforehand. We have move left, move right, and jump. Move left is A, move right is D, and jump is the space bar. So now inside of the physics process, we can use these. I'm going to create a variable called direction, and this is going to be the horizontal direction actually. Let's say horizontal direction. And we're going to set this to be input.getAxis. This will take in two input action names as strings. The first one will be move left, and the second one will be move right. GetAxis function will return -1, 0, or 1, depending on which one of these input actions are pressed. If the first argument is pressed, it will return -1. If the second one is pressed, it will return 1. If neither or both are pressed, it will return 0. This is perfect for our case because we can simply take this direction and multiply it with this 300 here, we're gonna make this a positive value. And now if move left is pressed, our speed, our velocity is negative. If move right is pressed, it's positive. And if neither are pressed, the direction will be 0, so the velocity will also be 0, because if you multiply a number with 0, it will become 0. Okay, so let's see this in action. At the start, I don't have any of the keys pressed, so the player is standing still. If I press D, we go right. If I press A, we go left. And if I press both, the player doesn't move, which is exactly what we want. Okay, great. So we can actually take this 300 here and turn this into a variable called speed, which I'm going to create up here as an export variable. Say 300. And the reason I'm making this an export variable is that you can click on the player in the scene tab here, and if you take a look at the inspector, the speed variable is visible from here because we declared it as an export variable. Now we can change the speed from the inspector without changing the script. Okay, great. So this takes care of the horizontal movement of the player. Now let's work on the vertical movement of the player, which is going to be the gravity and the jumping. Okay. So before we do this horizontal movement stuff, we're going to use a very useful function called isOnFloor. This function will return a Boolean value, a true or a false value, depending on the player's position. If the player is on a floor, this will return true. If the player is not on a floor, this will return false. So we can simply say if the player is not on the floor, let's take the velocity.y and let's set this to be a gravity value. And we're going to create this gravity up here as an export variable. And let's set this to be like 30. And we're actually going to apply this gravity each frame. So I'm going to say plus equals gravity instead of equals gravity. So each frame the player isn't on the floor, we're going to apply this gravity to the velocity.y value. Okay, so let's also print the velocity down here so that we can see what it looks like. Let's start the game. As you can see, the player is falling and the player just, disappeared. It fell outside of the gameplay area that we defined. But as you can see, the velocity is going up, 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 up by a crazy amount because we're not capping it. So what we're going to do here is after we apply the gravity, we're going to do a check. Let's say if velocity.y, greater than, let's say 500. Let's say velocity.y equals 500. So that the velocity just doesn't get bigger and bigger and bigger. And now, as you can see, the velocity is capped. I'm going to go back into the world and put the player at the top here so that we can see it a little bit more. As you can see now, the velocity is capped. I actually want to make this value a little bit bigger. So let's say 1000. Now you can see that the gravity is more. Okay, now we're going to do the jump. So after we do the gravity stuff, we're going to say if input is action just pressed jump. So if the player pressed the spacebar, we're going to say velocity.y equals jump force, which is going to be another export variable, and we're going to say negative jump force. Export var jump force, let's say, 300 maybe. So the reason we make this jump force negative is in Godot, the up direction on the y-axis is negative. So when we want to move the player up on the y, we're going to set the velocity.y to be a negative value. Okay, let's see this in action. So because we're not really checking for if the player is on the floor or not, we can actually jump mid-air currently with this setup. I'm gonna run the game and press spacebar, and as you can see, the player is jumping, but not nearly enough. And this is going to be a pain to test. So I'm gonna go into the world scene and create a ground platform to player to stand on. So let's create a static body 2D here. We can call this the platform. And this will have a mesh instance 2D. and a collision shape 2D. The mesh is just going to be some temporary, flat colored graphic that we're going to use. Let's set this to be a quad mesh, and let's give this a size of, let's see, 1000 by 150 maybe, by 100, let's say. That's looking good. Let's also create a collision shape of a rectangle, and let's give this the correct size. That's also looking good. I'm going to go into the mesh instance and give it a different color from the visibility, modulate, and I'm going to turn down the value here to make this a dark gray. Okay, now we can take this platform and put it below the player so that player has something to stand on. Now if we run the game, the player will stop here, and now we can test the jump. So let's press the space bar. As you can see, this jump is very weak, so let's go back into the player scene. We can change this from the inspector because we made these export variables. So I'm going to take the jump force and bump it up to be a 500 on the game. And 500 is better, but it's still a little bit weak in my opinion. So we can actually change this value while the game is running. So let's set this to be 600. 600 is nicer, but I think I'm going to set this to be 700. And yeah, 700 I think is a better value. As you can see, when we press the jump button, the velocity on the Y, which is this part here, will be negative, and then it will turn back into positive and start falling down. And once the player touches the floor, which is this platform right here, we don't have any more Y velocity because the gravity isn't being applied when the player is on the floor. Okay, so let's try jumping. And as you can see, it goes from negative to positive to 0. Okay, we basically have the beginnings of a platformer game. I'm going to create one more platform here so that the player has something to jump on. Let's take the platform, duplicate it, and put it here. Of course, we should create a camera for the player as well because this part here is outside of the, the default gameplay area. So I'm going to go back into the player scene. Create a camera 2D here. This is enabled, good. And I'm gonna take the camera and actually move it up a little so that it isn't on the dead center of the player. Like this. Now if we run the game, we have a camera on the player. And now we can go here and maybe jump here. Oh, the jump isn't strong enough, but we can double jump as you remember. We can actually jump as many times as we want, which isn't really something we want for the final game, but this is actually good for testing. So it makes things easier to test because we can just keep jumping and do stuff like this. And to fix that finally, let's go back into the player script. And after we jump, we can also say if is on floor. Only then we want to jump, and I can actually take this and put it next to here, like this. Oops, we don't need the if there. We can get rid of the if. And now we can only jump if the player is touching the floor. But I'm gonna turn this off for now. I'm gonna turn this part into a comment and put a semicolon here, not a semicolon, a colon here. Because, like I said, for testing, I want to be able to jump as many times as I want. So this is going to be it for this lecture. We have the beginnings of a platformer game. We laid the foundation and created the player controller. Welcome back, guys, to the 2D platformer tutorial series. In this one, we're going to create some animations for the player and switch between them in the player script. I found some assets on itch.io. This is an asset pack called Fantasy Knight Free Pixel Art Animated Character. I'm going to put the link in the description. It is a very cool asset pack of this pixel art knight that has a ton of animations that we can use to create a cool platformer character. Download this, and when you do, you're going to get the files and they're going to look like this. There are two different color options. I'm just going to pick the first one. It doesn't really matter. And in here, again, we have an outlined and no outline version. I'm going to pick the outlined version, but feel free to use the other one. In here, we have the PNG sprite sheets. And like I said, we have a ton of different animations here. In this video, we're going to use the idle, jump, fall, and the running animations, but in the future, we're probably gonna pick up some different ones as we implement more functionality, like the wall slide, for example. I'm gonna pick these and bring them into Godot, but before I do that, I'm gonna go into my project, go into the project settings, and in the textures tab here under rendering, I'm gonna set the default texture filter to be nearest. Because we're gonna use pixel art assets, we want to use the nearest texture filter that doesn't really blur the pixels in the texture so that the pixel art looks crisp and nice. Okay, now let's go into our file system, create a new folder here called assets. Let's create one more inside of assets, and that's going to be the textures. And then I'm going to select the textures folder so that when I bring the files in, they immediately go into that folder. I have them selected here. I'm just going to left click, drag them into my project, and they're going to get imported. And I have them here. Now we can go into the player scene. And instead of this Godot icon here, let's turn off the collision shape for now so that we can see it better. We're going to use this idle.png. We're going to switch between these as we try to play different animations, but first we're going to implement the idle animation. You can see that we have some scaling applied from the previous icon settings that we had. We're going to reset that, and also let's set the position to be lined up with the x-axis. We need to go into the animation settings. I think this one has 10 different frames, so inside of the animation settings here, we're going to set the horizontal frames to be 10. And we can see that by default, the player sprite is more in the left side because of the size of this image. So I'm going to go into the move mode and move this guy to the right about 3-4 pixels. And now we can actually start animating him. But if we go back into the world scene, you can see that the player is currently tiny. And that is because these are pixel art assets, so they're supposed to be small. Now we can either go into the player scene and scale this guy up, like this for example, so that the player looks bigger, or we can just change the window settings to be really small, which is what I'm gonna do. So let's set the scale back to be 1, and let's go into the project settings, to the window settings, and we're gonna set the viewport width to be 320 and the height to be 180. We're also going to set the stretch mode to be canvas items. This is going to make sure that the window scales up everything that we have when we make it bigger. Okay, so as you can see, the viewport is much smaller, so we can take the player in there. We need to save it here in the scene so that the scale change takes effect. And I'm gonna also bring in the platforms. They are too big at the moment. Let's delete the second one and let's change the size of the first one. Let's go into the mesh and make this much smaller like this. Let's do the same thing for the collision shape. Okay, looking good. Let's put this at the bottom and let's duplicate this and put the second one here. So we have the same setup. And I also want to go into the player and push the camera a little bit down right at the top of the player's head. Now we can play the game. And you can see that everything is looking good with the pixel art. And actually, I think I have a setting that I want to show you already taking effect. If you turn on advanced settings here, you'll get this window with override. I already have this set because I was testing, but for you, this isn't going to be set, so it's going to be 0, 0 like this. And if you try to play the game like that, you're gonna get this tiny window, which looks really funny. You can actually scale this up because we have the stretch mode enabled as canvas items, but you don't want to do that each time you try to play the game. So you can go into the window settings, turn on advanced settings, and set the window width override to something larger, like 1280 and 720. This is going to make sure that you have the window nice and big at the start and everything is looking good. We can still jump around and do this cool stuff that we were doing in the last lecture. Okay, great. Now we're gonna animate the player. So in the player scene, we're gonna create an animation player. we have two different options actually. We can either use a normal Sprite 2D like the one we have here and animate the animations using an animation player, or we can create an animated sprite node. In that case, we're not going to need an animation player, but I'm going to go with the animation player because it is going to give us more power in the future. We can do cool stuff like calling functions from a script mid-animation, for example. So because of that, I'm going to go with the animation player. Let's create a new animation. This is going to be the idle animation. It's going to be auto start because we want this to be the first one that gets played when the player gets instanced. This is also going to loop. Let's zoom out a little here and we're going to click on the Sprite 2D. An important thing here is we want to key the texture just like this. And we need to put this at the beginning. We also want to key the horizontal and the vertical frames of the sprite. And that is because we're going to switch between different sprite sheets, different textures here, because all of our animations are in a different PNG. So we want to keep the settings of that PNG when we make the change to a different animation. For example, if the idle animation has 10 frames, if another animation sprite sheet has 5 frames, and if we change to that one and change back to idle, it's going to be left as 5. And then the whole animation is going to look weird. And we also, of course, need to key the frames, all of them. So let's start with the first one. And let's key all of them by clicking here until we get to the end. And I think that's it. Let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's run the animation and see what it looks like. You can see that it is a very subtle animation of the night character kind of breathing and just being idle. That's good. Now let's move on to the run animation. I'm going to create a new animation here. Call it run. This is also going to loop. Let's key the texture, the horizontal frames. This one also has 10 frames, as you can see. Oh wait, did I even change animations? Images? No. Okay. I almost messed up there. So let's put this guy here and let's key this one. So instead of keying idle, we keyed the run animation. And this one also conveniently has 10 horizontal frames, so we can also key that. That's fine. And let's also key the vertical frames. And finally, let's key all the frames. This one will also have 10. And that's going to be the run animation. Looking okay. And let's also create one more called jump. Let's drag the jump.png into the texture. This one has 3 horizontal frames. So let's key the texture and key the horizontal frames. Let's also key the vertical frames. And we're going to put the length of this animation to be 0.3. And this will also loop. Let's zoom in a little and key the frames 1, 2, and 3. And we can play that and see what it looks like. It's looking okay. It seems a little slow to me, so maybe we can actually make this one 0.5 seconds long, 0.15 seconds long, excuse me. Zoom in a little, put the snap to be 0.05 so that we can scroll in smaller increments. And let's put these frames closer together so that the animation is faster. Okay. We want to do the same thing for the fall animation. Let's create a new one. This guy will also loop and be 0.15 seconds long. Let's click on the sprite, drag in the fall.png, key the texture, horizontal frames. This also has 3 frames like the jump. Let's also key frames. And let's put the snap to be 0.05 again and put these frames closer together just like that. Play. It seems a little too fast, but we can tweak this later if you don't like it. So those are all the animations that we're gonna use for now. Let's switch back to idle, and you can see that when I switch back to idle, all the texture and the horizontal frames, everything is switched as well, which is exactly what we want. Okay, so that is all for the animation player stuff. Now we're gonna go into the script and implement the switching of the animations. Okay, here we are inside of the player script. First of all, I want to create a reference to the animation player, animation player. We're gonna call this one AP because it is very cumbersome to type animation player each time. Let's also create one for the sprite. And here we're gonna do a bunch of things. First of all, currently, the player by default is looking to the right. We want the player to look towards the left when the player is going to the left, like this. We're a bit too fast right now. I'm actually gonna click on the player and set the speed to be like 200, maybe 150 even. Let's also put the gravity down a little and put the jump force also down to be 500. We can tweak these later furthermore when we're trying to make something nice, but I think this is going to be better for testing purposes so that we don't run out of platform. Okay, so when the player is going to the left like this, I want the sprite to be flipped. And the sprite has a very convenient feature. If you click on it, underneath the offset here, there's a flip H boolean. And if you turn this on, the sprite is flipped horizontally, basically. So we want to do this from the script when the player is going to the left. Okay, luckily, we already know the horizontal direction. It is this variable right here. This can either be -1, 0, or 1. And we know that when it is -1, that means that the player is going to the left. So we can basically say sprite.flip horizontal equals horizontal direction is equal to -1. So this expression right here will resolve to a Boolean value, a true or false value. And if the horizontal direction is -1, this will be true. If not, this will be false. So when the player is going to the left, we're going to set the flip H of the sprite to be true. So that it looks like this. As you can see, we're going to the left and the sprite is flipped. The problem is, as soon as I let go, the player is flipped again back to be the normal state. But we don't want that. We want the flip horizontal to be persistent. If the player is going to the left and we take our hands off, we want the player to still look at the left. How do we do that? We simply need to do a check here before we set the sprite flip horizontal value. We're going to say if horizontal direction is not equal to 0, let's do this. This means if the horizontal direction is 0, we're not going to do anything about the flip horizontal, which means when the player is going to the left and we take our hands off the key, the horizontal direction is going to be 0 and we're not going to change the flip H here. Okay, let's see this in action. Go to the right, go to the left, take my hands off, and you can see that the player is still looking to the left. Okay, so that's the first problem solved, and now we're going to switch between animations. Currently, we're playing the idle animation because we set that as autoplay, but we want to create a more sophisticated system here. So I'm going to create a new function down here called update animations, and this will take in the horizontal direction. And we're going to call this at the end of physics process and pass in the horizontal direction that we calculated. So here we have two different main cases. The first one is when the player is on the floor. The second one is when the player is in air, basically. So when on the floor, we want to play either the idle animation or the run animation. On the floor, in mid-air, we either want to play jump or fall. So we can create a simple if statement here saying if is on floor, else. If we're on the floor, we're going to say if horizontal direction is 0, this means we're not moving. So we're just going to say ap.play idle. So we're going to play the idle animation. Else, we're going to say ap.play run. Simple. Let's see. So when the player isn't moving, we're playing idle, and when the player is moving, we're playing the run animation. Okay, that seems to be working. Let's move on to the second case, which is when the player is not on the floor. In that case, we can basically check the velocity.y value, because we know that when the y velocity is negative, the player is jumping, going up, and when the y velocity is positive, the player is falling. So we're going to say if velocity.y is less than 0, we're going to play jump, else if velocity.y is greater than 0, we're going to say ap.play fall. And now, when the player is falling, we're playing the fall animation, and when the player is jumping, we're playing the jump animation, and it is a little bit too fast, I think, the animation, but we can fix that later. Okay, I also want to go into my camera here and maybe zoom out a little, because currently we're too zoomed in, I feel like, and I'm gonna move it a little bit down as well, 10 pixels like that, and let's set the zoom to be 0.65 maybe. Let's see what that looks like. Yeah, I think this looks nicer. Ooh, okay. Maybe the collision shape is a little bit too large. Did we forgot to fix that? Yes, we did. Okay. Let's make this much smaller, like this. Maybe like that. Okay. Before we end the lecture, there's one final thing that we need to fix, and that is the sprite. When it is flipped, half of the player is outside of the collision shape. This is because we moved the sprite 4 pixels to the right, because the default sprite isn't really centered on the y-axis. So to fix this, we moved them 4 pixels to the right so that it looks nicer and in line with the collision shape. But like I said, with this setup, when we flip horizontally, half of the player is outside of the collision shape, and it is not at all aligned with the center line as well, which is problematic. We can really see this take effect if you turn on debug visible collision shapes and play the game. You can see that when we're going to the right, everything is fine, but as soon as we turn left, half the player is outside of the collision shape, and we get funny stuff like this, where the player just falls down, and the arm of the player is inside of the platform there. To fix this, we basically want to move the player's sprite to the left side when the flip H is turned on. So when it is turned on, instead of putting it at 4, we want to put it at -4 so that it also looks correct. This seems to be the same for each one of the sprite sheets, so we can safely set this back to be 4 and flip horizontal to be off. So we can safely go into our script and create a function called switch direction. And instead of doing the flip horizontal here, we're just going to call switch direction. Before we had the sprite.flip H equals horizontal direction equals -1 here. This is what we had before. We're not going to do this anymore. We're going to call switch direction, and in here we're going to do that, and then we're going to say sprite.position.x equals horizontal direction times 4, so that when we're going to the left, the position is -4, and when we're going to the right, the position is +4. Okay, let's see this in action. I'm gonna play the game, and as you can see, the sprite is in the correct spot when we go to the right or to the left. Okay guys, great. So that is going to be it for this lecture. We have all the animations that we initially want for the player configured in the animation player. We're also switching between them in the player script. Great stuff. Welcome back guys. In this video, we're gonna add the ability to crouch to our player character so that he can go under obstacles like this. Let's get started. Okay, so there's a lot of things that we need to do, but first I'm going to create a box obstacle that we're going to use to test crouching. Okay, so this is going to be basically the same as the platform that we created, but it is going to have a different size and a different color. Let's create a static body 2D here, call it box. I'm gonna right click on this and save it as a scene, and we're gonna save this inside of the scenes folder as box.tscn. Let's go to the box scene that we just created. Here we're gonna create a mesh instance 2D and a collision shape 2D. Let's give the mesh instance a mesh. This is going to be a quad. I don't have any assets for this stuff yet, the props, so I'm just going with a basic mesh instance to give it simple graphics, but if you have assets that you want to use, feel free to use them. Let's give this mesh some size. Okay, I'm actually gonna click on the mesh instead of using these orange circles there and give it a size from here. Let's say 10 by 10 maybe. That's too small, isn't it? Let's go back. Yep, that's too small. Let's say 1000 by 1000. Would that be too large? Probably. That's way too large. Okay. My number game is off today. Let's say 100 by 100. And is that good? Still a bit too large. Let's say 75 by 75. Let's say 80 by 80. Okay, I'm gonna give this a different color. I will go into the visibility section here, click on modulate, and give this a brown color because boxes are sometimes brown, and I'm gonna respect their color. Let's give it a nice dark brown color like this. And then we're gonna create a collision shape. This will be obviously a rectangle. Let's give it the correct size. That's looking good. Okay, so that's going to be the box. Very simple, just a static body 2D, nothing complicated. And we're gonna use this guy. We're gonna put this guy here. Let's also take the player and put him here. As you can see, currently the player's collision shape is too tall to fit through this box, to fit underneath this box. So let's actually play the game and see that. As you can see, I can't go through the box. I'm too tall. And I also, I can't jump high enough. But imagine that there's no way for us to get there. We need some way of crouching to have this type of stuff in the game. So that's the main topic of this video, how to crouch. First of all, let's create the different types of animations that we're going to use. We're going to have two different states. The crouching state, where the player is crouched and standing still, and the crouching walking state, where the player is walking while crouching. So we're going to have two new animations, two new sprite sheets for that. So go into the assets folder that we downloaded in the last lecture. This will be available in the description if this is the first time you're seeing it. Here we have a crouch.png and a crouch walk.png. We're gonna select these and bring them into our project. Let's take them and put them inside of the textures folder. Okay, now let's go into the player scene and create two new animations. Create a new animation, call it crouch. This is going to be just a single frame, but we're still going to make it an animation so that we can use the animation player to switch between the different stuff that we need to do, like the texture and the horizontal frames and things like that. We need that stuff, so this is going to loop. The duration of this is irrelevant because, like I said, it is just a single frame. So let's click on the Sprite 2D. Let's drag in the crouch.png. The h frames is going to be 1. So this is the image. I'm going to key the texture. Let's get rid of that. Key the horizontal frames, the vertical frames, and let's also key the frame. So just a single frame here. And this is what it looks like. So that's the crouch animation. We're going to create one more called crouch_walk. And this guy will be, let's see, I don't know how many frames this has actually. So let's drag in crouchwalk.png. Let's see, it seems like 8, 1, 2, 3, 4, 5, 6, 7, 8. Yep, 8 frames. So let's key the texture. Let's key the horizontal frames, vertical frames, and let's start keying the frames. So 8 frames, we're going to put the duration to be 0.8. Let's zoom in a little in the animation editor here and start keying the frames. Once I start keying them, once I click on the key icon here, it automatically increments them, which is very useful. So I can just keep clicking on them until I reach the end, just like that. So let's see, 0, 1, 2, 3, 4, 5, 6, 7. That looks right. Let's play it. So this is the animation. Okay, so now we have the two different animations that we want, the crouch and crouch walk. Next, let's get the input to crouch from the player. To do this, we're going to create a new input action in the project settings. We'll call this one crouch, and I'm going to use the S key for this, but feel free to use a different key. So we're going to go into the player script, and in here, we're going to create a variable, a global variable called isCrouching. This is going to be a Boolean, so let's set it to be false by default, because when the game starts, we're not crouching yet. And we're going to have to get input in the physics process here. Someone in the comments pointed out to me that why are we getting the input, for example, for the direction in the physics process, because physics process is for physics related stuff. That person is right. We don't need to do this stuff here. We could put them in the process function, for example, like this, because that is arguably the better place to do it. We could put them here, make them global variables and use them in physics process. But it doesn't really matter that much. It's not going to really change anything here. So I'm just going to keep doing them in physics process, but just keep that in mind. Okay, so we can get this input after we do the horizontal direction, switch direction stuff here. We don't need this comment. I'm going to get rid of it. Create a new line here. And in here, we're going to check for input. I'm going to say if input is action just pressed, let's say crouch. We're going to say crouch, which is going to be a new function that I'm going to create. So down here, let's say function, crouch. And in here, we're going to do a check. If is crouching, let's return. Otherwise, let's set is crouching to be true. And then in the process function, we can print is crouching to see what it looks like. Okay, so by default, it's false. If I press S, it's true. And we're never setting it back to false. So let's do that now. So in here, we're going to say, oops, accidentally deleted that. We're going to say else if input is action just released crouch. So if we release the S key, we're going to say stand, which is also going to be a new function. And in this one, we're going to say if is crouching equals false. Did I misspell that? No, looks good. We're going to return. So if we're not crouching, we're not going to try to stand, of course. Otherwise, we're going to say is crouching equals false. Now we can play the game. I can try to crouch by pressing S. Is crouching is true. And then I can let go. Now it's false. So this is basically the code, architecture that we're going to use here. Now let's try playing the animations when we do these things. So when we crouch, let's say ap dot. Actually, let's not play the animations here because we have the update animations function here that we can use. Okay, so how do we want to do this? Let's see, if we're on the floor and let's see if the horizontal direction is 0, that means we're standing. Let's do a check for if is crouching. If we are, let's play ap.play crouch. Else, let's play idle. Let's do the same thing here in run. Let's say if is crouching ap.play crouch walk else run. And for jumping, the way I want this to work, let's see. Let's play this one first and see what it looks like. So now you can see that when I press S, the player is crouch, and when I let go, he stands up. Of course, we still can't go through these spaces yet because we're not changing the collision shape, which is what we're going to do to fix that. But currently it's just, looks, and it is looking good. I still want the player to stay crouched while jumping, actually. That might not be what you want to do in your game, but in mine, I want to be able to jump and crouch and, fit through holes and stuff. So I'm going to say if we're on the air, if is crouching equals false. So if we're not crouching, let's just do the normal stuff. And if we are, let's say ap.play crouch. So now we can play the game. If I'm crouched and I'm jumping, I stay crouched and I can do stuff like this. Yeah, so that's what I want to happen, and that basically covers the visual part of the crouching stuff that we're going to implement. Of course, I don't want to keep printing that, so where is that? Okay, we don't need you anymore. And now we're going to implement the collision shape stuff. Okay, so let's take a look at the player. I'm going to go into the debug settings and turn on visible collision shapes, and in here, if I run the game, you can see that the collision shape of the player is too tall to enter here. And we basically want to make this collision shape smaller when the player starts to crouch. We can do that in a number of different ways. First of all, I'm gonna bring this box a little bit up because currently, even if we crouch, it looks like it's going to be too low. So let's make it that much maybe. So now if we crouch, we should be able to fit through here. Okay, so the way we're gonna fix this is by creating different collision shapes, using different collision shapes. If you click on collision shape 2D, it has a shape property, and this shape is a resource. So we can save this to the disk and swap them when the player is crouching. So we're gonna have a collision shape that is this big, and we're gonna have one that is about this big, and we're gonna switch between those, basically. Okay, so firstly, I'm gonna click on this collision shape and take note of its size. So it is 16 on the X and 33 on the Y. I'm gonna make it 30 on the Y instead of 33 and put it down a little. Maybe let's say 32 actually. Okay, so 16 on the X, 32 on the Y. I'm gonna right click on this and save it. I'm gonna go into my root folder here, right click, create a new folder called resources. And I'm gonna call this night standing collision shape and save this. So now inside of our file system, we have this collision shape. So now I could, for example, reset this shape and bring this one back inside of from my file system, and I have the same things, the same properties here saved. So we're gonna do this one more time. I'm gonna reset this shape, create a new one, new rectangle shape, set the X size to be 16, and on the Y now it's going to be, it used to be 32, and let's maybe make this 24. And we're also going to need to change the position as well. So that's also going to be a challenge that we need to fix, because when you make the size different on a collision shape, the position also has to change in order for it to be, starting from the bottom, basically. So let's actually click on the animation player and switch to the crouching animation to see what this looks like. This size looks about right. So I think I'm happy with 24. So we're going to right click on this shape as well and save it. In the resources folder, we're going to call this night crouching collision shape. Great, so now we have both of our collision shapes inside of our file system. I'm going to reset this again and bring in the standing shape because that's what I want to have by default. Put it like that and set the animation to be idle again. Okay, so now we can go back into our script. We first want to preload these collision shapes because we're going to be switching them while the game is running, so we don't want to keep loading them. We're just going to load them once, which is what preload does. So let's create two variables up here to store these collision shapes. The first one is going to be the standing collision shape. We're going to say preload standing collision shape. And the other one is going to be the crouched or crouching collision shape. Let's say preload crouching collision shape. Good. And now we're simply gonna swap these in the crouch and the stand functions. So here I'm gonna say, oh, let's also not forget to get a reference for the collision shape. Collision shape equals collision shape 2D. We're gonna go down, and in the crouch function, we're going to say collision shape dot shape, which is what we were messing with. It's this property here. We can change it from our script, and we're going to set it to be, when we try to crouch, we're going to set it to be the crouching collision shape. And we're going to do the opposite in the stand function. We're going to say collision shape dot shape equals standing collision shape. Now with the visible collision shapes on, let's run the game. We're going to have a bug, but I just want you to see what this looks like. So I'm going to press S. And when I do that, you can see that the collision shape changes. And now we can actually go under this box here. But as you can see, the knees of the player is under this platform, because if you jump, you can see that the collision shape isn't at the bottom of the player. It's actually a little bit offsetted. And that's because the center of the shape is in the middle of the rectangle. So when we change its size or when we use a different collision shape with a different size, the position is not correct. So I can demonstrate this to you. So currently we have the standing shape, and the transform of the collision shape 2D node is -16. When I bring in the crouching shape, you can see that the collision shape got smaller from the top and the bottom. And the position, the Y position of the collision shape node is still at -16, but this is currently wrong. We want this to be down at -12 to compensate for the collision shape getting smaller. So take note of those values, -16 and -12, because we're going to use them inside of our script now. Okay, so let's put this back at -16 and give it the standing shape again. And let's go into our script. So to fix this, we're going to say, when the player stands, we're going to set the collision shapes position.y to be -16. And in the crouch function, we're going to set that to be -12. So this will fix the bug that we were having. So now I'm going to press S. And once I do that, you can see that the player is crouched and the collision shape is also swapped with the crouching collision shape. And now the player can go under things like this. Okay, so this is great, but there's still a bug that we need to fix. Currently, if we start crouching and we crawl under a box and we let go, you can see that the player tries to stand up, and we change the collision shape in the script. So now the player is basically too tall, the collision shape is too big to fit inside of the empty area that we have underneath the box. And in this case, Godot just goes into crazy mode, and anything can happen at this point. We could create a black hole and the whole universe could collapse. So that's not good. Let's hold down S and save our little knight. And in the next video, we're going to fix this by using Raycasts. So that's it for this lecture. We have the player crouching, and like I said, we're going to fix the bugs and some other stuff in the next one. Thank you for watching. I'll see you in the next one. Welcome back, guys, to the 2D platformer tutorial series. In this one, we're going to continue where we left off and keep working on crouching. In the last lecture, we implemented the basic functionality. Now when we press the S key, the player plays the crouching animation, and we switch collision shapes so that the player can fit through lower, smaller spaces like this one. So this is the basic functionality, and in this lecture I want to implement what happens when the player tries to stand up, but there's an object above the player that is going to intersect with the player's collision shape, because we're going to switch collision shapes, and with the taller collision shape, that is going to be a problem. For example, if I go under this box, you can see that my collision shape fits here, but if I try to stand, Godot will just go into crazy mode because we're trying to put our collision shape on top of another collision shape, and the physics calculations are just going nuts. So in this one, we're going to use Raycasts to detect if an object is above the player, and if so, we're not going to let the player stand and we're going to stay crouched. Even if the player lets go of the S key in a situation like this, we're going to keep him crouching, and when he crawls outside of the underneath the object, we're going to automatically stand him up because the player is not pressing down the S key anymore. Okay, enough explanation. Let's get to the implementation. Let's start by going into the player scene. In here, we're going to create a Raycast node. So let's create a new node, which is going to be a Raycast 2D. And we're going to need two of these actually. Let's first configure the first one. You can see that by default, the Raycast is looking down. And all a Raycast does is, it is basically a line that detects if anything is touching it or not. And by touching, I mean physics, collisions and stuff like that. So to change the position of the Raycast, we're going to change the target position in the inspector. I'm going to set this to be like -25. And I'm going to take it and put it on the left side of the player. And you're going to see why when we start using this. We don't want the tip to be exactly at the player's head level. but we also don't want it to be really up there. So this height looks fine to me. One important thing to have is to have exclude parent turned on, which is on by default. With this, the parent nodes, the collision shape and stuff like that will not get detected by the Raycast, which is important. So we're gonna duplicate this, but first let's rename it. I'm gonna rename this to be crouching, let's say crouch, Raycast 1. Raybast, okay, that's funny. Raycast 1, and let's duplicate it and put it at the right side. And we're gonna call this crouch Raycast 2. Okay, good. So that is all that we're gonna do in the scene editor. Now let's switch to the script. And in here, first, I'm gonna create references to these Raycasts. So let's say crouch Raycast 1. Crouch Raycast 1. Let's also get a reference to the second one so that we can use them easily inside of our script. And first, I'm going to demonstrate how to use these Raycasts. So let's go into, let's bring up the process function. Why not? And I'm going to say print, let's say crouch Raycast 1 is colliding. So this function is colliding will return true if the Raycast is colliding with something, and it will return false if it's not. And we can turn on, is it on? Yes. So visible collision shapes is on. So now if we play the game, you can see that we have two Raycasts here, and I'm going to go under this obstacle, and you can see that helpfully the Godot by default is rendering these lines in red if something touches them, if there's something colliding with them. So we didn't even need the console output actually, because that's enough to understand this. But you can see that when I go under something and the Raycast is touching with the box, we're returning true. And if not, we are returning false. So that is how we're going to use these things. If I go under something, I'm going to check is Raycast is colliding is true. And if it is, I'm not going to stand up. So it's very simple actually. And to be honest, it seemed to me like the Raycast is really up there. We actually don't want it to be that tall. Because I was looking at the standing image, so maybe it is more helpful to go into the crouching animation and then put the Raycasts like this. So that might be smarter. Let's see. Okay, so now let's take a look at it. Okay, let's go back into the script. So this is how we're going to use these. I'm going to get rid of this because we don't need it. So first of all, let's write a new function to detect if the area above the player is empty or not. So let's go down here, create a new function. I'm going to call this above head is empty. And this will return a Boolean. We can also denote that like this. It's not the best name for a function. I'm open for suggestions for a different name. Let's see. Okay, so this will return a result, and this result will be crouch Raycast 1 is colliding. Oops, not you, is colliding. And so this will be not crouch Raycast 1 is colliding and not crouch Raycast 2 is colliding. And we'll return result, which is a Boolean. Okay, so the logic here is very simple. If the first Raycast isn't colliding with anything and the second Raycast isn't colliding with anything, that means that the area above the player's head is empty. So if this is true, we're going to be able to stand up, basically. Okay, so the standing up is currently happening here. When the player releases the crouch input action, which is the S key, we try to stand. We're not going to do it this way. We first want to check if the area above the player is empty or not. Okay, so let's use the function that we just wrote. Let's say if above head is empty, we're going to stand. Else, currently let's not do anything. Or maybe let's say print can stand up, above head area not empty. Let's play the game. and I'm going to go under this box and let go of S. And you can see that the player didn't stand up, and we're printing can't stand up. The area isn't empty. Okay, and now I can actually walk around, and even though I'm not pressing the S key, I'm still crouched. But now we want to make it so that when the player goes outside of the box, we want him to immediately stand up, because currently we're not holding down the S key. To do that, we can actually create a variable that is going to hold some state for us. We can say stuck under object. So this variable is going to represent the fact that the player is actually under an object and he is stuck, meaning the player isn't trying to crouch, but the player can't stand up, basically. Okay, so we can set that variable here in the else statement. So instead of printing this, we can say if stuck under object isn't true. So if we didn't set this yet, let's say stuck under object is true. And we can actually print something, player stuck, setting stuck under object to true, just so we can see it when we test the game. And so if this is true, we're gonna, outside of these if statements here, inside of physics process, in this case, we're gonna keep track of this. So we're gonna say if, oops, I'm caps lock, okay, if stuck under object and above head is empty, let's try to stand. We also need to set stuck under object to false again, so that we don't try to do this again in the next frame. But here the logic is very simple. If we're stuck and the above head is empty, let's just stand. Okay, we can also print something here. We can say player was stuck. Okay, I guess that is fine. let's play the game and see if this works. So I'm gonna go into crouch mode. I can do the same stuff here. It still works. And now I'm gonna go under the box, let go, and you can see that we're printing player stuck, setting stuck under object to true. And now I'm gonna crawl outside of the box with the S key released. And now you can see that we printed player was stuck, but he is getting up. So I'm gonna do the same thing again, get under the box, let go. This time I'm gonna hold down S and we still get up. So that is also not good. So that's another bug that we just created, but at least we fixed the other bug. Okay, so let's take care of that next. Okay, actually see if you can fix that on your own, because it is not going to be that complicated. So if you want to give that a shot, pause the video now and give that a go. Otherwise, I'm gonna try to fix this, because this bug wasn't even in my plan. I just discovered it. So let's see. So when we try to stand, we should probably do a check if input is action pressed, let's say crouch. So if crouch isn't pressed, let's do this stuff. If it is pressed, we don't want to try to stand. So that will hopefully fix it. So I'm going to go under the box, let go, hold down S again and go outside. And this time I'm still crouched, so we didn't try to stand up in that case, which is good. So let's also let go of S again and go outside. In this case, I'm expecting the player to get up, and he does get up. And I can also do the normal crouching stuff outside of here. Okay, so finally, I just realized actually my placement of the Raycast is wrong, because if the obstacle is just above the Raycast's reach here, and if we try to play and we go under, right now we're not detecting it. So if I try to go stand, it will actually have the same bug here again. So I think I had the correct setup at the beginning here. So I'm gonna go back into idle, and I'm gonna take my Raycasts, and actually currently they aren't even aligned, so this one is a little bit, okay, now they're aligned. Okay, and I'm gonna make these guys, let's see, let's actually take them and just put them here. That's probably fine. Okay, so let's try this again, and this will be the final thing we do. And as you can see now, we also don't try to get up. And you can fine tune this, so this should probably stop trying to make us go down at this point, or maybe this, because with this we should be safe, but I think this will still detect. Yeah, it will still detect. So we can actually stand up here, but it is not letting us, so that is also not good. So let's go into the player and maybe make these a little shorter, like -22. Okay, let's try again. I'm just fiddling with this at this point. It is still detecting, so it should probably be the same height as the collision shape, actually. Now that I'm thinking, maybe just a tad bit, like a pixel longer. Let's see. Let's put it at -16. -16. So here, as you can see, it works. But let's actually get a few of obstacles here. Okay, so this should be no problem. Okay, we can't even get under this, so fail. Okay, so this works. We should also not be able to go stand up under this. This also works. But these ones we should be able to stand up under, and they also work. Now that is also fixed. Awesome. So that's going to be it for this video. Now the player can crouch, and we also fixed all the edge cases and the different types of functionality that we need to have. Thank you for watching. I'll see you in the next one. What is going on, guys? Welcome back to another episode of the 2D platformer tutorial series. In this one, I was thinking of adding yet another cool feature to our platformer character. I was thinking of adding a wall slide or maybe an attack animation to start the beginnings of the combat system, but then it hit me. The game looks horrible right now. Don't get me wrong, the knight looks awesome, but the background and the props look really bad. So in this one, we're gonna fix that by creating a tile map, import some assets, and set up auto tiling so that we can create levels blazingly fast. Let's begin. Okay, so let's start by creating a new tile map node. I'm gonna make this a separate scene so that we can use it in different scenes if we have to. Let's create a new scene. The root node is going to be a tile map, and for now this is going to be the only node we're gonna have here. The tile map needs a tile set, so we're gonna go into the inspector, click on the tile set here and click on new tile set. This will create a new tile set resource. We can actually save this to our file system, which is a good idea. So let's right click on it and click on save. Let's call this the default tile set and put this in the resource folder. Okay, so the tile set is going to need what is called an atlas that we can create from down here. As you can see, once we click on the tile map, we have two new workspaces that appear in the bottom panel. So if I click off of it, they're gone, but if I click on the tile map, they're back. The first one is the tile set workspace or the tile set editor, which is going to help us create a tile set and configure it. And the other one is the tile map editor, which is the one I'm on currently. I'm gonna switch to the tile set because this is the first one that we need to use. The tile map has to do with actually using the tile set to draw. So first of all, like I said, we need to set up the tile set. The tile set is the thing that the tile map uses in order to draw. This will make more sense as we start creating these. Okay, so for the tile set, we're gonna need a tile map. So I'm gonna click on my assets folder to textures, and then I'm gonna bring in some assets that I have prepared. The link for these will be in the description. These are from the same guy who made the knight, so hopefully they're gonna fit nicely. So we have this forest platformer tile set.png here. We also have some threes. We also might use these, so let's pick both and bring them into our textures folder. Nice, nice. And then we're gonna create a new atlas for the tile set. So let's click on the plus here and click on atlas. And then the atlas needs a texture, and this texture is going to be the tile map. So I'm gonna left click, hold on the tile map and drag it into the texture slot here. It's gonna tell me, do you want to automatically create the tiles? We're gonna say yes, which is going to make our work really easy. As you can see, all the tiles are automatically created here. This is a 16 by 16 tile set. And if you actually have the tile map selected, if you take a look at the inspector, it actually, firstly, you need to click on the tile set here, and then you can look at the tile size. So this tile size is very important. By default, it is 16 by 16, which happens to be the tile size of our tile set. But if we had a bigger tile set, let's say 32 by 32, we would have to change this to be 32 by 32. There are also different settings here, like the shape of the tiles. In our case, they're square, so that's the default value. But if you have isometric tiles or different types of tiles, then you need to configure those here as well. Okay, so believe it or not, we can actually start painting with this much setup. So back in Godot 3, tile sets and tile maps used to be a little bit of a pain, but with Godot 4, they're really easy to work with. So let's actually save this tile map, save the scene, I mean. Control S. Let's go back into the scenes folder and save this as the tilemap.tscn. Let's go back into our world scene and create an instance of the tile map here. And like I said, with this much setup, we can actually start drawing. I'm going to switch to the tile map editor instead of the tile set. Here we have a couple of tools that we can use to paint. The first one here is the paint tool. And while you're doing this, make sure you're in the select mode in the top toolbar here. So I'm in the select mode here, but here I'm gonna pick the paint mode and click on a tile that I want to draw. So let's pick this one. And then I can actually, up here, let's say, start painting with this. And I can pick these different ones and create a little platform here. And I can actually left click and drag to pick a pattern, which I just did here by mistake actually. So I can, for example, pick these two and then paint this part here. Just makes things easier, makes things faster. We're actually gonna configure auto tiling, which is gonna let us just paint, and everything, like all these different parts of the tile map, will just placed automatically in the correct spot. Okay, I'm gonna finish this little platform here, and as you can see, we painted the first platform. But the problem currently is that this has no collisions. So I can put the player up here and run the game, and the player will just fall through this platform because it doesn't have any collisions. So what we're going to do is we're going to switch to the tile map scene and create a collision physics layer for this. So the physics layer is the correct term. If you take a look at the inspector, we have, once you click the tile set here, the tile set has a physics layers section. And in here, we're going to click on add element. And this will create a new physics layer for the tile set. Then we're going to switch to the tile set editor here. So this is the tile set editor. And in here, we're going to go into the select section. This mode lets us pick individual tiles or just pick multiple ones by holding down shift and clicking on the ones that we want. I'm going to select all of these guys because I want all of these to have a collision shape. So with these selected, I'm going to go into the physics tab here, physics layer 0, and down here we can create a collision shape for these. Because I have all of them selected, the collision shape that I create here will be set for all of these. I'm going to click on this plus icon here to start creating my shape, and I'm going to click on the edges here to create a rectangle. And I think I forgot to pick this guy, so I'm going to click on that one as well and also create a collision shape here. Now I made all of these to be squares, but if you look at these ones, for example, the edge ones, these are not really squares. They have a little bit of blank space here, so you can actually adjust the shape here, for example, like this. You can create more points, and then you'll have a better looking collision shape. I'm not going to bother doing those right now because it's going to take a lot of time. So we're going to push through. I might do them, after I make this video. So if you want to do that, you can do that. Okay, so with this, we should have collisions happening for our tile map. So let's go into the debug menu here. we have visible collision shapes on, so if I run the game now, we should be able to see the collision on the tile map. And you can see that we have the collision shapes correctly being created for each of the tiles. And you can see that this part is slippery because we made it, not a square shape, which might not be what you want actually. So yeah, that's up to you. Okay, so we actually have a working tile map right now. And we could, go ahead and use this, go into the tile map and pick, a tile from here and start using it. But like I said, it's going to be a pain drawing these by hand one by one. So we're going to set up auto tiling. Okay, so let's go back into the tile map scene. To set up auto tiling, we're going to click on the tile map, go into the tile set from the inspector, click on it. And in here, just like we created a layer for the physics, now we're going to create a set, a terrain set. So Godot calls auto tiling terrains. So in order to use them, you need to create a set, and you can have multiple of these. So we're going to create a terrain set, and the terrain set needs a terrain. So we're going to click on this chevron here to open up the terrain section and click on add element again. Now we have a terrain set, and the terrain set has a single terrain. Okay, so let's use this terrain set. In the select mode here, we're gonna select these guys again. So let's turn off the physics section, and I'm gonna select all of them again. And we're not gonna use all of them actually. We're gonna use these two, and also we're gonna use these two as well, but we're not gonna use the rest of them for the auto tiling. Okay, so with these guys selected, I'm gonna go into the terrain section here. And by default, the terrain set and the terrain for these is set to -1. And that means that they don't have a terrain set or a terrain. We're going to set this to be 0, first the terrain set, and then the terrain. 0 doesn't mean null, or it doesn't mean empty. In this case, 0 means that for example, this has the terrain set index 0 and the terrain index 0. So the indices for the terrain set and the terrain start from 0. Okay, so now that we have the right terrain set and the terrain set for all of these, we're going to go one by one and set their auto tiling configuration. Okay, so let me explain to you how this works. So I'm going to click on this middle one here, and I'm going to go into its terrain's peering bit options here and make this a little larger. So this has an option for each of the, the parts of the tile. If you take a tile and split it to, 9 different sections, the top left, top side, top right, left, right, center, and bottom left, bottom, and bottom right. So there's an option for each of those areas. And what we're going to specify is when to use these tiles. So for example, the center one, we want to use this tile when all of the tiles that cover this tile are filled. You can actually see that very clearly here in the tile set image. So all of the tiles, like the top side, the top sides, the left and right sides, and the bottom sides are filled. So only in that case, we're going to use the center tile. But for example, this top left part here, we only want to use this one when the bottom side of it, bottom right side of it, and the right side of it is filled. So okay, let's start setting this up. I hope I'm not doing a horrible job explaining this. Okay, so let's begin. So this center one, like I said, we're going to set all of the parts to be filled. So by default, these values are -1, and that means empty. So -1 means empty and 0 means filled. So I'm going to set all of these to be 0. And you can see that the tile map editor, the tile set editor, is doing a good job visualizing these parts. So I selected all of them to be filled. So this all of the tile is filled. Now we're going to pick the top left section here. And like I said, we're going to fill the right side, bottom right, and the bottom for this. And we're going to leave everything else to be empty. Bottom right, right side, and the bottom side. We're going to pick this top center piece, and this one is going to be the left side and the right side, bottom left, bottom right. Let's see, right side, bottom right, bottom side, bottom left, and left side. And for this one, the top right edge, we're going to have the left side, bottom left, and the bottom side. So I hope this is making sense to you. And we're basically going to create a square here. Okay, I'm gonna speed up a little and do all of these. So this one is going to be the left side, top left, top side, bottom side, and the bottom left side. This one is going to be, let's see, top left, top side, left side. This one is going to be top side, top left, top right, left side, and the right side. This one will be, let's see, right side, top right, and the top side. And finally, this is going to be the right side, top right, bottom right, top, and the bottom. And then we're gonna move on to these guys in the right side here. So these will be the ones that are in the edges where, you know, two rectangles meet, two rectangles of tiles meet. So these two will be for the bottom side, and these two will be the top side. These ones are a little bit more difficult to understand from just looking at this, but when you see them in action, you'll understand what they do. So let's see. So this one on the right will have all of the parts selected, but the top left. And this one will have all of them selected, except top right. This one will have all except bottom left. And this one, everything except bottom right. Okay, so with that, we have all of the auto tiling stuff configured, and now we can actually test it. So let's first test here, maybe in the Tilemap scene. So we can go into the Tilemap editor here, and from here we actually need to go to this terrains option. So by default, you will be in this tiles option here, and from here you can paint individual tiles or pick a pattern. You can also use these different painting tools here. You have a line tool, for example. So you can paint in lines. You can also paint in rectangles. So you can do stuff like this, or you can use this fill tool, which will fill in betweens of a shape that you have, the empty spots. You also have an eraser here that you can use. Okay, we're gonna go back into the paint mode here, and we're gonna switch to the terrain section. And from here, we can use the terrain that we just created. You can also see the terrain set and the terrain, you know, we created in the inspector. So we have a single terrain set and a single terrain, but as you create more of them, they will appear here. So I'm gonna pick terrain 0, and I'm actually gonna pick the rectangle mode here. Or first, let's start testing with the paint mode. I'm gonna pick the paint mode and start painting. And you can see that all the tiles are being placed automatically. And I can paint and paint and paint, and it will look correct. And we can actually speed this up by clicking on the rectangle tool here and start creating rectangles. And you can actually see those corner pieces here. It seems like we made a mistake maybe here because that's not correct, but this one is correct. And for example, let's see. Here, this one is also not correct, so we probably made a mistake there, but this one looks correct, and this one also looks correct. So the bottom ones look right, but the top ones we didn't do correctly. So let's go back into the tile set. In the tile set, I probably mixed these up. So for this one, it is going to be probably, let's see, the top left side. That is going to be empty, and this one, let's set the top right side to be empty. Let's save. Let's go back into the tile map, pick the terrain, and let's pick the paint tool and paint here. Now you can see that it is correct. And we can also test it with the rect tool, do some of this stuff like this, and it is all looking good to me. Okay, so this is the auto tiling feature. I'm actually gonna click on the eraser here and pick all of this to get rid of it and save this scene. And then now we can go back into the world scene. And in here we can create a better looking, layout. So we actually don't need these platforms anymore. We can delete them. From here, let's delete them. And let's put the tile map at the top here. I'm gonna pick the tile map and go into the terrain again, pick the terrain and create a ground here that we're gonna use. We can leave the boxes here. We can actually use them. Let's get rid of this part here. Let's run the scene. And I'm gonna turn off the visible collision shape so that we can see the art a little bit better. And now you can see that we have a nice looking, floor / ground tile. And we can actually make this even look better by using layers, because we actually have some, if you take a look at the tile set image here, we actually have some grass that we can use. But if you zoom in here and try to use this grass with this setup, it's not gonna work because, let's pick the tile map here, go back into the tiles, pick the grass, for example, and try to paint. And you will see that the ground, the dirt layer disappeared. So this isn't the way that we want to do this. The way we're gonna achieve this is by using layers. So let's go back into the tile map scene and let's close this terrain sets option. And down here, outside of the tile set, there's a section called layers. So by default, we have a single layer. We're gonna name this one the ground, and we're gonna create one more layer, and we're gonna call this the grass. And we can set the z-index for the grass to be 1 so that it appears above the ground all the time. And now when we paint, you can see that there's a layer option here, and we can pick the ground layer or the grass layer. And the grass layer will be displayed on top of the ground. Okay, so I'm gonna save and go back into the world. In here, in the tiles section, in the tile map editor, I'm gonna pick the grass here and start painting. As you can see, it didn't work because I forgot to change layers. So I'm gonna undo that and pick the grass layer this time. Now when I paint, I actually have 2 different variations of the grass here to make it a little bit more unique. So let's choose these ones randomly. But you can see that I can paint on top of the ground with this layer setup that I have here, which is really nice. And we can use these edge tiles here to make it look good, just like this. Now when I play the game, the ground looks a little bit more nicely with the grass. Okay, so there's a lot we can do with the tile map. This is just scratching the surface. Godot 4's tile map node is extremely powerful, but this video is already very long, so I'm gonna cut it here, and in the future maybe we'll play with the tile map more. Thank you for watching this video. I'm always working on new videos and new courses for you guys, so if you want to get notified when I make new stuff, make sure to join my email list. There's a link in the description. Once you do that, you'll get cool stuff like discount codes for my courses or beta access for the games that I'm working on and stuff like that. Thank you for watching again, and I'll see you in the next video. Hello friends, in this video we're going to implement Coyote Time into our platformer character. So first of all, let me explain what this is and why we need it. In many 2D platformer games, Coyote Time is implemented so that the game feels a little bit more responsive when the player jumps just before the player starts falling. So for example, here we have the player, and let's say the player is running to the right. At this point, the player's collision shape stops touching the box. If the player tries to jump now, it's not going to work because is on floor is going to be false. If we take a look at the script, you will see that right here, let's get rid of that comment. Right here, we're checking if is on floor is true before we jump. So because of that, this jump here is not going to work. But that's going to feel very unresponsive, and the player is going to feel bad because they just missed a jump. And the player might not even feel or see that the collision shape, stopped touching the ground here. They might just think that the spacebar didn't work or something went wrong. So in order to fix this, Coyote Time is going to let the player jump for a very short amount of time after the player stops touching the ground. And also during Coyote Time, the gravity isn't going to affect the player. So basically the player is going to be able to go like this without falling, and then they're going to be able to jump, but just for a very short amount of time. So that is what Coyote Time is. Let's go ahead and start implementing this. First of all, we're going to go into the player scene and create a timer. We're going to call this the Coyote Timer. In the end, we're going to set this to be something very short like 0.1, but for testing purposes, just for now, let's set it to be 1 second. This is going to be a one-shot timer because we want this to stop after it times out. We don't want it to start again. Now we need to start this timer right when the player stops colliding with the ground in this frame. That's what we want to detect. So let's go into the player script and see how we're going to do this. So we know that we have a function called isOnFloor that is going to return true if we're touching the floor and false if we're not touching the floor. We can take advantage of this and check it before we move and save that in a variable called wasOnFloor. And then we can check it again after we move. And if wasOnFloor was true, that means before we moved, we were touching the floor. And if it is false after we move, that means we just stopped touching the floor in this very frame. So to check for that, we're going to create an if statement, and we're going to check if we were on the floor. So if wasOnFloor is true, and if isOnFloor's current value is false. In this case, we're going to say false. Let's test this. And to actually test this, I'm going to make some changes to our scene. I'm going to create another box right here. I'm also going to change the box's z-index so that it is behind the tile map. Let's click on the box. Let's go into ordering here and set the z-index to be -1, just like that. And then I'm going to put the player above it, just so we can test this a little bit quickly. Now when we fall, we should get the fall print statement, as you can see. But currently this is also going to trigger when we jump, because currently the if statement is also checking for that. We were on the floor and we're not on the floor anymore. That also includes jumping. So to only check for the falling case, we're going to create another end here and say velocity.y is greater than or equal to 0. Let's say y, because as you know, when we jump, we set the velocity to be something negative. So if it is 0 or if it is greater than 0, that means we're falling or we're staying on the ground. Now we should only be checking the falling case. As you can see, when I jump, we don't get it, but when I fall, we get the if statement. Perfect. So now we know the exact moment in the game that we start falling. Here we're going to start the Coyote timer. And then we're going to, let's see, we didn't get a reference to it, so let's do that up here. onReadyVar Coyote timer equals Coyote timer, just like that. Then I'm going to connect the timeout signal of the Coyote timer to a function. I'm also going to take that function up just underneath the physics process, just right here, so that we can see it easily. And then I'm going to create a Boolean variable, which is going to be can coyote jump, which is going to be false at the start. But when we start, right when we start the Coyote timer, we're going to set it to be true. And then when the timer is over, we're going to set it to be false. And while this Boolean is true, the player is going to be able to jump while it's in the air, basically. So how can we do that? Let's take a look at the place we make the player jump. Right here. Currently we're checking if the jump key is pressed and isOnFloor is true. Now there's another case that the player can jump. Can coyote jump equals true. So instead of making this check here, let's take it, let's create another if statement, and let's say or can coyote jump. So if the jump key is pressed and if is on floor is true, or if can coyote jump is true. So if either of these is true, then we're going to be able to jump. And if we did make a coyote jump, we're going to check for that again, and we're going to set it equal to be false. We can also say print coyote jump, just like that. Okay, this should be working now. We can test it, although it is not complete because we're still gonna fall even inside of the coyote time, but we can implement that after we test it. Okay. So let me just run the game. Whoops, not the scene. Let's run the whole game. And I'm going to fall and try to jump mid-air. Let's actually do it here first. And as you can see, while the coyote time is active, I can jump. And we get the coyote jump print statement. We don't normally get that, but if I try to jump while in air, we get it. Just like that. Okay. So the final thing to implement here is making the player not fall while the coyote time is active. So to do that, we're going to take a look at the place we implemented gravity, which is right here. Now we want to not add the gravity here if the coyote time is active. So to do that, we're going to say if we're not on the floor and can coyote jump equals false. Also in this case, we don't want to increment the gravity into the velocity.y. Okay, let's take a look at this. I'm going to walk off the edge and we should be, standing on the ground basically. As you can see, until the coyote timer times out, which is 1 second long. Just like that. And while I'm in the air, I can jump. And now I can do stuff like this. Which looks funny. Okay, so this means the coyote time is correctly working, and the final thing to do here is going to be setting the coyote timer's wait time to be something reasonable so that this is actually making sense. Ideally, you don't want the player to, detect consciously that there is coyote time. They shouldn't be able to tell the difference. So it should be very, very subtle, because if they can tell the difference, then it's just going to feel weird. So because of that, we're going to set this to be 0.1 seconds, which I think is a good value. So let's try it out. Now, as you can see, I'm still in the air for a very short amount of time, but it's very difficult to notice actually. And I can still jump just like that. As you can see, those were all coyote jumps. And yeah, this is it basically. I just missed it there. That is good. You don't want to be able to hit it all the time. Just like I said, needs to be very subtle. And it's just going to make the game feel a little bit nicer, because it's going to let the player basically cheat a little. Okay, so that's it. That is Coyote Time. I hope you liked this. If you did, leave a like, comment, subscribe, all that stuff. Thank you for watching. I'll see you in the next one. Hello friends. In this video, we're going to implement jump buffering into our player controller. So first of all, let me explain what this is, and then we're going to implement it. Okay, let's say that the character right here is falling to the ground, and the player wants to jump. So they press the spacebar right before the character right here touches the floor. Let's say right here. Currently, this jump is not going to get registered because the player isn't touching the floor. And that's the check we make before we jump. So if we take a look at the player script, when the player touches the jump key or presses the jump key, we check if we are on the floor. And if we're not, then we're not going to jump. So in this scenario, the player or the character is simply going to land on the floor and not jump. And from the player's perspective, that's going to feel bad. And that's because the time frame that they missed the jump is so small that they're not really going to be able to see it. They're going to think that they pressed the spacebar, but the game didn't work, the player didn't jump. It's overall not going to feel good, and it's going to frustrate the player. So in order to fix this, we need to make the game a little bit more forgiving in this regard. So that's where jump buffering comes in. So when the player, tries to jump while in air, we're going to save that jump, and once the character touches the floor, we're going to jump. So that's what jump buffering is basically. Now let's go ahead and start implementing this. We're going to go into the player scene here and create a timer. We're going to call this timer, let's see, the jump buffer timer. The jump buffer time is also going to be very short, just like the Coyote time. In the end, it's going to be 0.1 seconds, but just for testing purposes, to make testing a little bit easier, I'm going to put this at 0.3 seconds. We'll change this at the end, and this is also going to be one shot. Let's go into the script. Let's create a reference to this timer. Jump buffer timer. Kind of a long name. Jump buffer timer, just like that. And I'm also going to connect, let's see, I forgot to put the assignment operator there. I'm also going to connect the signal, the timeout signal. Let's take that function and we'll place it below the Coyote timer's timeout function, just like that. And the first thing we want to do here is we want to save that buffered jump when the player tries to jump while in air. Okay, so in order to save that, we're going to create a Boolean variable. I'm going to call this jump buffered. It will be false at the start. And we're going to set this to true if the player tries to jump, but the jump doesn't work. So right here, we're making the player jump. But let's create an if-else statement here. So in the case that the jump didn't work, and that's going to be because the player is not on the floor, in that case, we're going to say jump buffered equals true if it is false. So we're going to say if not jump buffered. So if it is false, let's say jump buffered equals true. We can also print something and say jump buffered true. Oops. And of course, we're going to start the jump buffer timer as well. And then once the timer times out, we're going to set jump buffered back to false. Right here. And in here, we can also print jump buffered false. Okay, so let's test this. Now we should be able to try to jump while we're in the air. That's going to trigger the jump buffer timer. And then once the timer times out, we're going to set the, let's say false. We're going to set jump buffered back to false. Okay. So I'm gonna try to jump while I'm in the air. And as you can see, that triggers the jump buffer timer. And it doesn't work if I just do a normal jump after landing, as you can see. Okay, great. So now that we're saving, the fact that we have a buffered jump, we need to actually, make the player jump once they land on the ground. So we need to be able to detect the frame, the moment in the game that the player touches the ground. So before we call move and slide, the player should be here. And after we call move and slide, the player should be touching the floor or the box or whatever. So that's the moment in the game that we're trying to detect. And we can easily do that after we call move and slide using the was on floor variable here. So let's think about this. If we weren't on the floor before moving, and after moving, we are on the floor, that is the exact, moment in the game we're looking for. So we can simply say if we weren't on the floor. So if not was on floor and if is on floor, so if is on floor returns true after moving, that means we just touched the ground. So we can test this by printing touched ground. And now once the player lands, we should print touched ground. As you can see, that is perfect. That's exactly what we're looking for. Now inside of this if statement, we're going to make the player jump if there is a buffered jump. Before I do that though, I'm going to create a couple of comments here. Let's say touched ground for this. And for this one up here, this is started to fall. Okay. So in here, we're going to check if jump buffered is true. And if so, we're going to set it to be false because we're going to use the buffered jump. Then we're going to print buffered jump just so we can see it. And then finally, we need to make the player jump. Currently, the code that makes the player jump is up here. We want to use this again. So because of that, I'm actually going to turn this into a function. So let's cut all of this code from here, create a function called jump, place it here, fix the indentation just like that. I'm also going to get rid of these prints, jump buffered true and jump buffered false. We don't need them anymore. And in here, we're going to say jump again. And this time, this part of the if statement is going to get called and the player is going to jump again after they touch the floor. Okay, let's give this a shot. I'm going to try to jump while I'm falling to the ground. And as you can see, it's working. If I land and jump again, it doesn't work. That's a normal jump. But if I try to jump while I'm in the air, it's going to say buffer jump, which is exactly what we're looking for. But of course, there's a time frame for this. For example, if I press the spacebar early before the 0.3 seconds that we have currently, it's not going to work. As you can see, I press jump while I'm here, and when I fall, it doesn't work because the timer has timed out. Okay, so now that this is working, let's put the wait time of this to be 0.1 because 0.3 is just too much and it's going to feel weird, but 0.1 is going to be the sweet spot. So now if I try to jump right before I touch the ground, the jump is still going to count. And you can test this first without jump buffering and after with jump buffering, and you're going to see a very big difference. This is going to make the game feel a lot better, I promise. It's such a bad feeling when you try to jump and it doesn't work and you just land flat and then you have to, press the spacebar again. It just makes the game feel really bad, but this really fixes it. And yeah, that's going to be how to implement jump buffering. I hope you liked it. If you did, please leave a like, comment, subscribe, and I'll see you in the next video. Hello friends, in this video, we're going to implement variable jump height to our player controller. Currently, inside of the game, we only have a single jump height. So even if we hold down the spacebar, or even if we tap the spacebar, we jump the same height. What we're going to do is we're going to only jump a little when we tap the spacebar, and then we're going to do a normal jump when we hold the spacebar down for a longer amount of time. So because there's time involved with this, we're going to create a timer, and we're going to start the timer when we press the spacebar. And if the timer times out, when the timer times out, if the spacebar is not being pressed, then we're going to turn this into a short jump. But if the spacebar is still being pressed after the timer times out, we're going to go ahead and do a normal jump. So the way this is going to work is we're going to do a normal jump. And like I said, if the spacebar is released, when the timer times out, we're going to turn it into a short jump. Okay, so let's go ahead and start implementing this. Inside of the player scene, let's go ahead and create a new timer, which is going to be the jump height, let's say, jump height timer. This is going to be very short, so the wait time is going to be something like 0.15 seconds. and it's also going to be one shot. Let's create a reference to this right here. Jump height timer. I'm also going to connect the timeout signal. A lot of these different mechanics have to do with timers, which is interesting. We had to create one for Coyote Time, for jump buffering, and now for the variable jump height. Okay. So like I said, what we want to do is we want to start this timer when the spacebar is pressed. Right here. So we'll say jump height timer.start. And like I said, we're going to go ahead and do a normal jump. So you might have thought that we're going to do a small jump, and then if the spacebar is pressed for longer, we're going to turn that into a big jump. But like I said, it's the opposite. We're going to do a normal jump, and if the spacebar is released early, we're going to turn that into a shorter jump. So let's go to the timeout function right here. And when the timer times out, we're going to check if the spacebar is still being held down or not. So we're going to say if not input is action pressed, jump. So if the spacebar isn't being pressed anymore, and else, in the else case, we're just going to say high jump. And we don't need to do anything else because the spacebar is still being held down even after the timer timed out. So in that case, just go ahead and do the normal jump. But in the case that the spacebar is released after the timer times out, we're going to go ahead and turn this into a smaller jump. Doing that is going to be very simple. We simply need to set the velocity.y to be 0 to stop the jump and let the player fall down, and gravity is going to take care of that. But we only have to do this, we should only do this if velocity.y is less than 0, meaning we're going up. Okay, so we can go ahead and test this. This is going to work, but it's not going to look good because we're setting this to 0, and that's going to suddenly stop the player while it's going up, and that's not going to look very good. So nonetheless, let's take a look at what this looks like. I'm going to do a normal jump first, so I'm going to hold down the spacebar. And as you can see, that does a high jump. But if I tap it, as you can see, that's going to do a low jump or small jump. And the time frame here is determined by the wait time of the jump height timer. So after I press the spacebar, if I take my finger off from the spacebar, during those 0.15 seconds, that's going to be a small jump, but if I keep it down, it's going to turn into a high jump. So let's also print low jump here, just like that. And like I said, let's take a look at that again. When we do the low jump, it looks very rigid and abrupt when we start falling down. I don't like that, so in order to make that a little bit smoother, instead of using 0 here, we're going to use a number like 100, which is a number I tested and it looks good. But you can also do something like -80, 90. You can play with this to see the number that you like. The important thing here is we're setting the y velocity to be something that's less than what it is currently. And usually when this happens, when this if statement takes into effect, it's usually in the range of -200. So setting it to be -100 should, stop the jump, just like 0, but it's going to do it in a more smooth way, like I said. Okay, hopefully that's all clear. Let's take a look at this again. I'm going to do a small jump or a low jump, and as you can see, it's much smoother. Let's also do a big one, just like that. And with the big jump, we should be able to make it to the top of this box, but with the small one, we shouldn't be able to, as you can see. And everything else that we built, like the Coyote jump and the jump buffering, should also be working with this. So for example, if I'm holding it down, I can do a high jump with jump buffering, as you can see. But I can also do a small jump with jump buffering. And same with the Coyote jump. That was a low jump with the Coyote jump, and that's a high jump with the Coyote jump, as you can see. everything is working just fine. And now we have a very good, very, nice character controller that has a lot of features. And you can take this and basically turn it into your own platformer game if that's what you want to do. But yeah, that's going to be it for this one. This is how to do variable jump heights in Godot 4 for your 2D platformer controller. If you liked it, make sure to leave a like, comment, subscribe, and I'll see you in the next video.